you have assignments for me, send them forward, please. The reason for doing all the identities is to solve equations involving trig functions. A basic trig equation is a single trig function of an angle equals some number. So the goal is to solve something, trig function of theta equals constant. And my goal is to do this in the same way as often as possible. So because trig functions are periodic, I want to start with just one period, whatever the one base period is. So if I'm doing sine or cosine, we'll go 0 to 2 pi. If I'm doing secant, cosecant, same deal. Unless there's been an adjustment to my period. More on that later. If I'm doing tangent or cotangent, that base period is of length pi. Once I have that, I then add periods to it. And then, but last but by no means least, I want to use my technology. I want to check this against the results out of the calculator, against the graphs, against whatever other information I have. Now, in a lot of cases, these are problems we've already solved. We found particular solutions. That was a question on the exam. Find all values between 0 and 360 degrees where we have a particular sine or a particular cosine, right? So if I do something like I don't just want one solution. I don't just want two solutions. I want all the possible solutions to this equation. All right? Let me start with the first period. Sine of theta, period is 2 pi. So between 0 and 2 pi, one surrounds the unit circle. What angles have a sine of root 3 over 2? And the answer is in radians, unfortunately. Okay?
Pi over 3.
Pi over 3 in the first quadrant, absolutely. But just within the unit circle, that's not the only one. Because we're looking at sine. Where else can sine have a positive value? What other quadrant? The second quadrant. Sine, all S, sine. Okay. So there's another one in quadrant 2. What's the angle in quadrant 2? It's the one whose reference angle, pi over 3. Say again?
3 pi over 6.
3 pi over 6 is the same as pi over 2.
Yeah.
5 pi over 3 is in the fourth quadrant, not the second quadrant. If it helps, let's draw the unit circle. Pi over 3 is up here. The other angle we said was over here in the second quadrant. Its reference angle is pi over 3. So what's the rest of it? 2 pi over 3. Perfect. That's the first step. Within the first period, I found my answers. Great. We said the period of this equation was the period of this trig function. Period of sine of theta. 2 pi. So I then need to add all multiples of the period, which means I take the pi over 3 and I add any multiple of 2 pi. So n here represents an integer. Positive integer, negative integer, doesn't matter. But I have to do that to both my solutions. So there are 2 infinite families of solutions here. Point of order. I don't like writing pi and then the n. So usually I will write 2n pi instead of 2 pi n, but that's just me. You'll see it in the book that way more often than not. So now I think I found all the possible solutions. Let's check. How? Well, I'm going to graph both equations, both sides, as separate equations on here. So I'm going to graph sine theta, and I'm going to graph square root of 3 over 2 as 2 separate equations. And if I'm correct, I should see crossing points for those 2 curves. I want to make sure I'm in a window that will show me more than one period. So I'm going to go to the window. That's an absolute crap window for this game. I can use the zoom option and go to the trig setting. I'm sure you're in radians. And then I will see from roughly minus 2 pi to 2 pi in the x-axis. Zoom 7. Come on. Stop. Zoom 7. Doesn't help if I don't hit enter. There's my sine curve. There's square root 3 over 2. I'm going to blow it up a little, make this bigger top to bottom. Instead of going from minus 4 to 4, go minus 1.5 to 1.5, then I'll see more of the top of the sine curve. It'll look bigger. I'm hoping that's pi over 3, and that's 2 pi over 3. So let's hit the trace button and type in pi over 3 as an x value. And I should see my little blinking cursor move to this crossing. That's exactly where it is. I could ask the calculator to find the crossing, but then I'd have to recognize the decimal. Since I put in the number instead, I'm sure that's the decimal value for pi over 3. 2 pi over 3, same way. 2 pi over 3 should be here. Yep. And this is going to repeat every period, right? Because it's the same behavior on the right side and the left side of this curve. Shifted back one period. So if I did pi over 3 minus 2 pi, that should be here on the left. So that's the same solution moved back one period. And I can do the same thing for the other one. 2 pi over 3 minus 2 pi. I don't even have to do the simplifying first. And that's the other solution on the left side. And we check as many periods as we want. Make sense? Questions? Dan, you're still looking at this like you don't like it.
What's the purpose of this?
My goal is to solve this equation. All I wanted to make, this part is just to make sure I got these right. To see, hey, is that where theta is equal to this number?
Okay.
That's why I put them in there. Did I get that right when I found these numbers? Because if I'm working with a reference angle, an angle in my chart, this is easy to get these. But what if I'm not? One-fourth is not a number I recognize as the sine or cosine of any angle I already know. That's not on my chart. That's not on my unit circle. I don't know that one. In one period, what is the period of cosine of theta? Okay, 0 to 2 pi?
No, 0 to, like, isn't it like basically 2 pi pi, the quadrant 1 and 2?
That's where something else is true. Where does cosine repeat itself? One whole wiggle of the cosine function takes how long? That's still 2 pi. But cosine inverse, because I don't know what this angle is, the only way to find it is to use an inverse function. And the cosine inverse is only defined for the first two quadrants. So this answer is either in quadrant 1 or quadrant 2. Which quadrant will that be in? One, because the cosine is positive in quadrant 1 and negative in quadrant 2. Now, I don't know what this number is, but I can find it. Cosine inverse, 1/4. That's in radians. Here's one type. And again. But that's only in quadrants 1 and 2, and cosine has a period of 2 pi. So that's quadrants 1 and 2 only goes up to 1 pi. There's another angle in which quadrant? Quadrant 4. So I'll even make a note to that. This is in quadrant 1. So now I need to know what the quadrant 4 version is. There's my first angle. And it came and hit the x-axis at 1/4. That's what it means to have a cosine value of 1/4. That means that my other angle is down here. What's the value of that angle? How did you get 3/4? Using? I was going to say the 1/4 and the 3/4 is the way we break up this horizontal piece, right? 1/4 of it is here on the left and the other 3/4 of it is on the right. That doesn't help me with the angle. But that's this one up here.
Right, but it's the same. That's all along the x-axis, so it's gonna be the same point, no matter what.
Ah, but it's now down. David?
75.
I don't know what degree measure this is at all. 75 degrees would still be in quadrant 1, wouldn't it? No, I want to know what this bottom angle is. I want to know what, see, this is the 1.318. I now want to know what's this. How? If I add 180 degrees, I'm going to end up over here. 180 degrees makes a straight line, right? So 180 degrees would take me down into quadrant 3. This is a reference angle question.
Is it 2 pi minus 1?
Exactly. It's the whole circle, take away the 1.38, 1.318 that we folded down. So I'm going to call that 4.965. This is why I need to know, once I have the reference angle, how do I get the rest of them? And in this case, that's exactly what I've done. I've figured out what the remaining piece of the circle is. Now, we could also have used this part, right? That is just negative 1.318. But the reason I didn't use that angle is because it's not between 0 and 2 pi. And I did say when I started that I wanted to use the stuff in one period. If I let my period go from negative pi to pi, then that one would work, right? That's still a width of 2 pi. You can play with this. It's your choice. Okay, that's step 1. Find the answers in one period. Again, I still see some furrowed eyebrows and some questioning looks. Talk to me, people. I now need to add the period. We said the period of this function was 2 pi. If I'd used the negative 1.318 up here, then I could say down here, use that. Let's check. See if we got it right. So this graph, instead of sine, is now cosine. And instead of root 3 over 2, I have a quarter. I'm on the same window. Boom. If I'm correct, on the right-hand side of this graph, those should cross at 1.318 and 4.965. Let's actually let the calculator find the intersections for me. Second, trace is the calculate menu. And option number 5 there says intersect. So I can ask the calculator, hey, where do these two things cross? And they'll say, which two things? Oh, the first curve is the equation cosine of x. Hit enter. See, I put a little mark on the graph there. The second equation is 1/4. Hit enter. There's the little mark on that one. And then it says, where do you think they cross? You get close to where you think they cross, and hit enter a third time. And it thinks about it and says, oh, those cross at 1.318. Exactly where we want them. And then I can do the same thing for this crossing over here. Second, calculate option number 5. The first curve is the cosine curve. The second curve is the horizontal line. And I think they cross somewhere over here, 4.965. Say again? I used Zoom option number 7 to get this window. And then I went and changed the y's to be negative 1.5 to 1.5. Are you in degrees or radians? Because if you're in degrees, those will say like negative 300 and something. Make sure you're in radians for this. More questions?
Why do we subtract 1.318 from 2 pi?
Ah.
You only do that when you don't know radians.
Why did I do this? No, I do that whenever I'm trying to get the angle in quadrant 4. If I'm in quadrant 4, my reference angle, if the angle is here, then this is the reference angle. Right? But look at, if I put those two together, I get the whole circle. So the two of them added together have to give me 2 pi. That means that the angle is 2 pi minus the reference angle. So whenever I'm in the 4th quadrant, that's my way of finding from the reference angle what's the other angle. Now cosine is even. What does it mean for a function to be even? Something about the picture and symmetry and something like that.
About the y-axis.
If I flip left to right, it's the same, yes? And we see that the cosine part of this graph on the left is exactly the same as the cosine part on the right. And that's why I can use 1.318 and negative 1.318, because everything that happens on the left side and the right side has to match up perfectly. That's why I could have used the other angle in the negative section there. But that only works with cosine, because cosine is even. Wait a minute. Cosine is even. Cosine is even. So is secant. I use it for that one too. I haven't gotten to those yet, but we'll get there. More questions? Now this is, again, from the textbook. I've modified it slightly. The textbook asks not just to find the answers, but give 6 specific answers. This is an extra step I do after having done all the stuff in the previous problem. So let's do the same thing we did in the previous problem and solve this from scratch. Cosine theta, period, is 2 pi. So I need to find the solutions in that first period. Root 2 over 2, cosine is positive in the first quadrant. So what's my answer in the first quadrant? 45 degrees, pi over 4. But if it's positive in the first quadrant, positive in the fourth quadrant, what's that? You have two choices. 7 pi over 4 or minus pi over 4. Realistically, your call. As a matter of fact, I think at the moment, because I keep saying that I want to use the unit circle as my base period, I think this one is easier to work with, the 7 pi over 4, but that's a personal preference. I know that a lot of people actually think of the unit circle in a different fashion. And they think of the unit circle not as going this way from the right, but going from the left. And then we're going from minus pi to pi, aren't we? In which case you'd use this one. I don't care, because what I'm going to do in the next part changes that. Here, it says, in general, pi over 4 plus 2n pi, or 7 pi over 4 plus 2n pi, n an integer. Oh, I'm going to give you a shortcut. Instead of writing out the word integer each time, the symbol for the integers in math speak is this funky font Z. That's called a blackboard bold font because we don't have bold-faced pens. In our bold-faced chalk, it's kind of hard. You write with the side of your piece of chalk to make the letter bigger, so we just made the extra piece in the middle bigger. And then to say that n belongs to this set, we use that little funky looking E, which means membership or element. N is in the integers. So those two things say the same thing, but this is math speak. David, I wanted 6 specific examples, right? Pick a value for n. If I pick n equals 1, I get pi over 4 plus 2 pi, which is 9 pi over 4. If I pick 7 pi over 4 plus 2 pi, that'll be 15 pi over 4. If n was 0, I would have pi over 4, 7 pi over 4, right? If n is negative 1, then I get pi over 4 minus 2 pi, which is negative 7 pi over 4, and I get 7 pi over 4 minus 2 pi, which is negative pi over 4. So does it show up when you do the n is negative 1, or does it show up when you do n is 0? If you picked up here, if you picked minus pi over 4, then that would show up here. And we just rearrange which one goes with which value of n. So which one is easier to work with? Which one do you like? I wanted 6. 1, 2, 3, 4, 5, 6. I'm good. Excuse me. Questions? Talk to me.
Zero is acceptable.
Yeah, n can be any number, any whole number you want. That's what an integer is, positive, negative, or zero. If you want to pick 1 and 2 and 3, that still works. You'll just give bigger numbers than I did. What I'm doing when I pick that value of n is I'm picking which period I want to be in. So this is the period where n is 0. This is the period where n is negative 1. Negative 1, 0, 1. And thus I found 1, 2, 3, 4, 5, 6 crossing points. You want to do 1, 2, 3, we just go to another wiggle on the other side, right? Further to the right. You want to pick negative 2, that just means we go one more wiggle to the left. That's exactly what this n represents, is which period are we in.
We saw when the word intersects.
Which means we should check, right? Trace. I think 15 pi over 4 is an answer. Trace, put in 15 pi over 4. Oh, wait a minute. It helps if I have the right equation, doesn't it? Square root 2 over 2. Gotta have the right line on there, don't you? That looks like 15 pi over 4. Might be in the right place. Trace 15 pi over 4. Yep, there's crossing point. Whew. Had a minute panic there. What do I like? Oh. Graph, not the math. I'm okay with that. More questions? (99.9% of the time, when I'm trying to solve a particular equation, I'm almost always getting it by setting something equal to 0. So this to me actually looks more typical of what I would see. Rather than equals a number, I want it to be equal to 0. Most of the equations we solve, set something equal to 0 and figure out what the x's are. All right. But with 2 steps, this turns into trig function equals a number. Because I just rearrange. And that's exactly the same sort of problem as the very first one we did. Except I see a 1/5. What does that mean I have to do? If I do the triangle, I can get the other trig functions. I can't get the angle out of the triangle. Do I get the angle out of the triangle? I take my inverse function. So in quadrant 1, I do the inverse. And again, I want a radians answer. Which is an ugly decimal. Okay. I will learn to live with my disappointment of ugly decimals. 0.201, good enough. I was only going 3 decimal places so far. Where's the other angle? Which quadrant's the other one in? This is sine, right? The other one's in quadrant 2. It's just, what do I do? It's pi minus this one. I want the rest of it. So it's pi minus the reference angle. And again, the 3 decimal places, I get this. So that's step 1. What's step 2? Add the period to each of these answers. What's step 3? Draw a picture, check your work. Now, in this case, you actually have 2 options. You could graph this equation and look for the crossing points. Or you could graph this equation and look for the x-intercepts. Let's do it that way. 5 sine theta minus 1. Now you'll notice in this trig window that's the default, I don't actually see the bottom of the graph. Why not? Because the amplitude of the trig function is 5. And this window only goes up and down by 4. So I need to change the window to actually see the whole curve. But I only care about where the curve crosses the x-axis. I believe this crossing should be at point 201, and this crossing at 2.94. I can try and type those in, or I can ask the calculator, where is the y value 0? Now, when I ask it to find a 0, it's going to do a little algorithm that's going to move back and forth and check, oh, we went from negative to positive or positive to negative, and we're going to keep getting that window to be smaller and smaller. So the way in which I find a 0 is a little bit different than the way I find an intersection. I'm going to hit enter, and it's going to ask me for a left bound. So it's going to say, give me a mark that you know is to the left of where we cross the x-axis. There, I'm sure that that's to the left of where we cross. And it says, give me a right bound. Notice it put up a little flag that says, that's your left edge. Then I can give it a right edge, so I move over to the right with the keypad here until I'm sure I'm on the other side. I hit enter again, and it says, okay, I'm going to look between those 2 flags. Give me a guess where you think I should start. So we get close to where we think we should start. Hit enter a 3rd time. 1201. Make sure the other one is 2.94, not 2.940.
did you choose the plot on the point beyond the origin?
So I went and hit calculate 0, and then I used the arrow keys to move the little cursor over to where I think I'm looking. So I said, oh, this is to the left of where I think it's crossing. Hit enter. I need to now be on the right of where I think it's crossing. Hit enter. Give me a guess. You don't actually have to move to give it the guess. I could give it the guess, use the rightmost side to start. And it'll find the crossing point. Did that one work better, Dan? Now, I will say that solving this and checking my work graphically makes this verify step a lot easier. The graphing calculator in my high school was a computer in another building. So we didn't do this. Doing this visually to me is very helpful. And if I'd done it the other way around, sine x and 1/5, going to be a lot smaller. Probably have to change that Y. I see the same crossing points. Let me change the window so we can see a little better. There's my sine curve. There's the 1/5, but now I can do the calculate intersect version. The only reason I chose not to do that one is in case I made a mistake doing the algebra to get from here to here. Because if I made a sign error or a division error or something, getting from here to here, then I would have gotten this one right, but I wouldn't have gotten that one right. So I'm of the opinion that you should go back to the original equation you were given rather than a modification of it. Again, personal opinion. Questions? If I do a problem in secant or cosecant, I just turn it into a problem of sine and cosine. So I don't have to do anything different if I'm working with an equation in secant. I may have to be careful about what I do. Let's try this one. Just like the previous problem, this is not set up as trig function equals a number. It's set up equal to 0. So I grab my identities. Secant becomes walk me through what you did, David. Okay. Like that? One problem. Small problem, but one problem. Take a square root. two options. Right. Which means I actually now have to solve two separate equations. I have to solve secant theta equals positive root 2, and I have to solve secant theta equals negative root 2. So unfortunately, that square just doubled my workload. Okay. I don't remember the values for secant and cosecant as easily as I remember the values for sine and cosine. So let's switch. What do I switch with secant? Almost. Secant isn't cosine, secant is, no, secant is 1 over cosine. I have to remember that 1 over. Because I want to get the cosine all alone, which means I need to flip both sides of this equation. And that makes cosine equal to 1 over root 2 and negative 1 over root 2. And here is where my brain lurches. What? 1 over root 2? All of my reference things are over 2, not over root 2, right? What's an equivalent fraction here? Root 2 over 2. If I rationalize the denominator here, there are a lot of places where I use 1 over root 2 because it's quote unquote easier. But when I think of my table, it's all over 2's. I need the rationalized version. Well, now I need 2 answers for the one on the left and 2 answers for the one on the right. Here, the cosine is positive. That's an angle in quadrant 1, and an angle in quadrant 4. Here, the cosine is negative. It's an angle in quadrant 2, an angle in quadrant 3. So I get 4 distinct, separate answers. In the basic first period. Root 2 over 2 goes with what angle in the first quadrant? And in radians, that's pi over 4. So in the fourth quadrant, I'll use 2 pi minus that. And that's 7 pi over 4. Negative root 2 over 2. That's got a reference angle of pi over 4, but we're in the second quadrant. So what's my reference? What's my regular angle over here? In quadrant 3, 5 pi over 4. And then I add 2n pi to all of those. Please notice each and every one of these is one of those 45-degree reference angles. So really, it's like I took the same angle and just went 90 degrees and 90 degrees and 90 degrees and 90 degrees and 90. So you could write this in a bunch of different ways for the answer in the back of the book. But I think that works perfectly well. Now, I don't know how to graph secant on my calculator. I have to graph it in cosine terms, which means I can't actually graph the original version of this equation. I have to graph in terms of cosines. So when I go to graph this, I'm going to write it as 1 over cosine, that's my secant, squared. And then I can set this equal to 2. Normally, you think of secant, it goes up, it goes down, it goes up, it goes down. But when I square it, all the negatives become positive. So everything is on the top. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. There are my 4 intersections in the first unit circle. Whew. Questions? Did you get something different looking?
No, I just typed the wrong thing in, so
That absolutely, yeah, easy to do. If I'm working with tangent or cotangent, the basic period is not 2 pi, it's 1 pi. So if I go to solve a problem in tangents, I need to remember the basic period for tangent is 1 pi. Tangent gives me answers in quadrant 1 and 4, cotangent in quadrants 1 and 2. So this answer is in quadrant 4. I can use the negative angle here if I'd like. What's an angle whose tangent square root of 3? Wait a minute. Tangents with sines and cosines, right? So I could think of this as root 3 over 2 and 1/2. And then I could say, oh, well, sine of theta is going to be root 3 over 2. Cosine of theta has got to be the 1/2. What angle does that? I was going to say, it's got to be one of those. That's all the options we have from our table. Wait a minute. The sine is bigger. Y is bigger. That's the steep angle, not the shallow angle. So that's 60 degrees. But it's down. So it's negative 60 degrees. And I'm in radians. I don't want to be in degrees. So I get negative pi over 3. But my base period is 1 pi. Now, if you chose not to use minus pi over 3 and use the positive angle instead, you'd get 5 pi over 3. But that's the same as picking n to be 2. You could also pick 2 pi over 3. That would be the same thing as picking n to be 1. So this answer came from my inverse tangent idea, but it's not the only way to get this angle. And if I needed to, I have an inverse tangent button. Let's graph this, see if we got it right. Tangent of x, negative square root 3. Here I am on my basic trig window. My first answer is in quadrant 4. Negative 2 pi over 3. 5 pi over 3 minus 4 pi over 3. I think I got these right. Trace. Negative pi over 3 is that crossing point. 5 pi over 3 is that crossing point. In the second period over, where n was equal to 2. Whew. Questions? Rather frequently, I run into problems with mixes of trig functions, combinations, products, sums. I want to be able to solve equations like those as well. But that means solving something like this, which I agree looks rather vomit-inducing. But that means I need to think of this algebraically. I see a cosine squared and a cosine. Rather than drop an F-bomb, my brain says this is a quadratic. But it's a quadratic in cosines. So I'm going to make a simplifying substitution. I'm going to make this look nicer, so I can do the algebra in a nicer way. If I, instead of writing 4 cosine theta, I write 4u, well, then I could replace the cosine squared with a u squared, which makes this equation 4u squared minus 4u plus 1. And that's a regular, ordinary quadratic equation. And I know how to solve those. I've known how to solve those since last semester in algebra, if not longer. Solve that quadratic. You can either factor it, use the quadratic formula, use completing the square, do whatever you want to figure this one out. But I want to solve a quadratic. Now I will say 100% I cheated. This one factors nicely. Because this one happens to be a perfect square. Which means I set each factor equal to 0. That's really the same thing. And I get u equals 1/2. But I don't care about solving this in u. I care about solving this in theta. So let me go back and undo my simplifying assumption. And now I get a trig function just like we were looking at earlier. I know what to do. Cosine. Cosine is positive. Which quadrants am I in? First and fourth. If the cosine is 1/2, that's on my reference list. Which angle is that? Over 3. Which means in quadrant 4, you have two choices. You want to use minus pi over 3 or 5 pi over 3. It doesn't matter. But now, you add a period and you solve this problem. And once again, I can draw a picture to check. But I'm probably going to have to graph the original equation to make sure that this all works. So I go back all the way to the original equation. 4 cosine squared minus 4 cosine plus 1. I want to know where that's equal to 0, so I don't even have to graph anything in the second equation. I just have to look for where it crosses the axis. Doesn't look like a trig function anymore because of the squares that are floating around in there. I get a much weirder looking picture, don't I? But there we are, pi over 3 and 5 pi over 3. Oh, and negative pi over 3. Negative 5 pi over 3. Because it's all in cosines, it's still even. You sneaky bugger. Questions? This means I need to steal all my tricks from last semester about factoring. What do I do first? Where do I start?
Factor out cosine later.
Okay. And if I do that, what is left behind in the factoring? And since that's equal to 0, either the first piece must be equal to 0 or the second piece must be equal to 0. So again, this turns into two separate problems. Now the one on the left is cosine theta equals a number. Do a little more work with the one on the right. But now I'm 100% capable of figuring out what angles do this and what angles do that. Those are the problems I've already solved. What angle has a cosine of 0? $90. That's one answer. What's the other answer? 3 pi over 2. And those technically aren't in quadrants. They're between quadrants. But one's in the top half of the circle and one's in the bottom half of the circle. That makes sense. Like we got one in quadrant 1 and 1 in 4, 1 in 2, 1 in 3 when we were dealing with cosine, one in the top, one in the bottom. What about over here? My sign is negative. Which quadrant am I in? Three and 4. Okay, if the reference angle would be in quadrant 1, where is sine equal to 1/2? First quadrant.
Where is sine equal to positive 1/2?
Right, where is sine equal to positive 1/2?
5/6.
So that's my reference angle. The reference angle is pi over 6. What's the angle in quadrant 4? Again, I think the circle helps. I need to know the angle in quadrant 4. I need to know the angle in quadrant 3. So that's here. What was the other one? Because it's 2 pi take away the 1/6. So that's 12/6 minus 1/6. And this is 180 degrees more. So it's add a whole pi. If I'm right, in the first period, there should be 1, 2, 3, 4 solutions. But that means in general, pi over 2 plus 2n pi, 3 pi over 2 plus 2n pi, 7 pi over 6 plus 2n pi, and 11 pi over 6 plus 2n pi. So let's graph and see if I got it right. Type in my original equation. 2 sine x cosine x plus cosine x. Hit enter, and I graph that on my trig window. My trig window will show me one period on the left and one period on the right. I should see a total of 8 crossings of the x-axis. 4 on the left and 4 on the right. Pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6. I hope. Let's check. Trace. Pi over 2. Yep. 3 pi over 2. 7 pi over 6, 11 pi over 6. And all of that is with n equal to 0. This is where n is equal to -1. Well, it's not one sine curve anymore, right? Because this equation is all of this. It's not a single sine curve. So it doesn't look like one wave, it looks like this mishmash of a bunch of them glued together. And what we're really doing is we're taking a regular cosine curve and we're multiplying it by this so that regular cosine gets kind of blown around by this multiplication. Regardless of what I have to factor, the fact that I can factor allows me to solve what look like much more complicated equations much more simply. Let me just do the factoring. What would I factor? Yeah, I can take the tangent theta out, right? So then I get tangent theta times what? So again, either tangent of theta is 0 or 3 sine theta minus 2 is 0. Tangent being 0 is one I know. But when I go to do this one, I get sine of theta equals 2/3. And that's not one I know. So on this side, I have to use the sine inverse button. But that's okay. I'll get a decimal. Oh. Sine is positive. I should get an answer in quadrant 1. I should get another answer in quadrant 2. Tangent. I'll have a different period. The period on this one is 1 pi. The period on this one is 2 pi. So make sure that when you write the general answer, you do it both ways with the correct periods. Yes?
If I didn't see you do it right there, I would take out tan theta, that would have left 2 tan theta sine theta minus, because, so why, like in the past, when you factor out, you have 3xy and 2xy, you factor out an xy.
But I didn't have 2xy, I only had 2x. When I factored out the x, there was nothing else left behind. I pulled the tangent from here and the tangent from here. Everything else stayed to go in those parentheses. If I have the need for the identities we've used so far, then these problems will need that formula sheet. That's what we're going to do in the next section. But something you need to remember is that our next class meeting is a week from today, because on Tuesday we have the Founders Day celebration. There are lectures in the morning in Cecilia Hall, in admin parlors and admin 206. There is a panel discussion in the afternoon. There's rededicating the greenhouse. There's a luncheon. There's a ticketed talk in the evening. You should have gotten an email from the president's office about all the options and the full schedule. Go to these things because they're worthwhile. There's a lot of fun stuff happening too as well. Go read the schedule. I will see you all in a week. Have a wonderful rest of your day.